Jai Hind to all. I am Komal Rani, Assistant Professor at Ajay Kumar Garg Engineering College. Today we will discuss various rules of inference which are covered in the discrete structure and theory of logic. Okay, so let's discuss the basic rules or inference in proposition logic. So here we have decided two terms. Okay, the first one is the premises and the second one is the conclusion. So what is premises basically? So premises is a proposition on the basis of which we will able to draw a conclusion. If we will able to draw a conclusion, so you can think of premises as an evidence or assumptions. So basically there are two types of statement. The first one is the valid statement and the second one is the invalid statement. So valid statement is always true in any circumstances. If we have taken the two variable P and Q, so whatever be the fourth values, four types of condition, it will gives you always true value. Then we can say that this is a valid statement, or based on that valid statement we reach at the conclusion. So otherwise if we got any false from all four things, so we can't reach at conclusion, because for one condition we will fail. So whenever we will at one condition we will fail, so we can fail anytime. Okay, so this is an invalid statement. So based on invalid statement you can't reach the conclusion, but based on valid statement you can reach the conclusion. So, okay, so the premises is like a similar way. If we will able to draw a conclusion, so premises as an, we can think the premises as an evidence. We have evidence or we have assumptions, based on that we can say that we can draw a conclusion. If we are not able to draw a conclusion, that will be a invalid statement. Okay, therefore initially we assume something is true. So in the premises case we will initially always assume that whatever be the premises, it is always true, and on the basis of that assumption we draw some conclusion. The conclusion can be true and the conclusion can be false. Okay, so conclusion, what is conclusion now? So conclusion is again a proposition that is reached from the given set of premises. So based on that premises we reached at the conclusion. So you can think of it as a result of the assumption that we made in an argument. So argument is a sequence of statements that end with a conclusion. Okay, so next discuss valid argument. So valid argument is said to be valid if and only if it is not possible to make all premises true and a conclusion false. Okay, so we can say that sequence of statement to be valid statement if it is not possible to make all premises true and a conclusion false. That means conclusion should be, if all premises are true, conclusion should be true value. Okay, so some examples of an argument. If I love cat, then I love dog. So what are the premises? P1 is there, if I love cat, and then I love dog. So P2 is cat, I love cat. Okay, and what is the conclusion here? Therefore I love dog. Okay, because condition is that if I love cat, then I love dog. So first premises is true, I love cat. So what's, you can draw the conclusion here. Therefore, because the premises to say that I love the cat, therefore you can say that I love dog also. Okay, so here P implies Q. So if then conditions will be described with the help of the implication. Okay, so P implies Q is true and P is true. So that means Q is true. That is the valid argument. Okay, because result is true and premises is true, the result will always gives you the true value, and true value gives you the valid argument. As discussed, valid argument are those arguments which will give you the true value in any circumstances. Okay. The second one is, if I love cat, then I love dog. Okay. Now, I love dog, therefore I love cat. You can see P implies Q. Suppose F, P is F. I love cat, then I love dog. Okay, this is P and this is Q. Okay, so P says that I love cat, but here and thus implies Q says that true value. Okay, so this is true. When you will expand this is negation of P and Q on this is Q. Okay, so initially we have taken this is false. Okay, then this is true and this is true. So here this is here we have taken the false value and here we have taken the true value. So true will become the false. Okay, so here I think this is the disjunction in nature. Okay, so it will gives you the false value. So this is the invalid argument, because from that, because I love dog, the first condition true, then second is true. Here we can say, here we say that I love dog, therefore I love cat. This is not a condition, but the condition is this: if I love cat, then I love dog. So this is a false statement will give you, that means this is an invalid argument here. Okay. So next is there are different rules of inference which are template for constructing a valid argument. This is very much important topic. Okay. Various rules of inference. So let's discuss one by one. So first is the modus ponens. So what does modus ponens say? That if P implies Q is true and P is true, that means Q is always true. Or you can represent here that P implies Q is true and, okay, P is also true. So that implies Q is also true. Okay. The second one is modus ponens. Modus ponens says that if P implies Q is true, okay, and negation of Q is true, then negation of P is also true. You can say that like this: P implies Q is true and negation of Q is true, that means negation of P is also true here. Okay, so this is false implies false, this is true, and negation of P is true. So here we have taken P implies Q. Okay, P is true and the Q is true. So P is false and the Q is false. Okay, so you can write here negation of P and Q. Okay, and negation of Q. So negation of P is equal to true, or here negation of that is also true. So this is will give you the true value, this is true, the result will also a true value. Okay, so when you expand P implies Q, you will get that statement. Okay, so you can modus ponens says that if P implies Q is true, negation of Q is true, then negation of P is also true. Third is the hypothetical syllogism. So what's the hypothetical syllogism? Says that if P implies Q is true, Q implies R is true, that means P implies R is also true. Okay, so similar way you can choose the P implies Q is true, that means negation of P and Q imply R, that is negation of Q R, so that means P imply R, that means negation of P R. So here we have taken all the true value. Okay, so here this is false union true, false union true, and false union true. So the result will always give you true, true and the true. Okay, so this is the hypothetical syllogism, or you can write like this way. Okay, next is the disjunctive syllogism. So what's the disjunctive? As the name says, the disjunctive, that means the disjunctions are there. Okay, so P disjunction Q and negation of P is true, then Q is also true. So here again we have taken P false and the true Q is true. Okay, false true is equal to true and the negation of P is equal to true, that means Q is equal to true. You can write here like this also. Next is addition. So if P is true, then P disjunction Q is also true. So P implies P disjunction Q here. Next one is the simplification. P disjunction Q is true, then P is true. That is the opposite of this addition and the simplification. Okay. The last one is conjunction. So conjunction, as the name suggests, there should be a symbol, conjunction symbols there. If P is true, Q is true, then P conjunction Q is also true. You can write here P is true, Q is true, implies P in conjunction Q. Okay. And the last one is the resolution. What's the resolution? Say that P implies Q is true and the negation of P conjunction disjunction R, so Q disjunction or is always true. You can write here P disjunction Q conjunction negation of P disjunction Q implies Q disjunction R. Okay, so these are the various inference rules. These are very much important rules from the paper point of view. Okay, or you can, if you want to draw any conclusion from the logical equation, okay, you can use these rules directly to find the two statements are logically equivalent or not equivalent. So how to build argument using rules of inference? Next we have to draw some premises, and based on that premises we have to draw the some conclusion. Okay, so if it does not rain, if it is not foggy, then the sailing race will be held and the life saving demonstration will go. If the sailing race is held, then the trophy will be awarded, and the trophy was not awarded. So here's premises are there. So what's the conclusion? It rained. And finally trophy was not awarded. That means it's rain. Okay. So R is the premises that it rains. Second premises F, that is it is foggy. Third premises is that the sailing race will be held. And the fourth premises are that the life-saving demonstration will go on. And the fifth premise is that the trophy will be awarded. But what's the conclusion here? The trophy was not awarded. That means, what's the conclusion? It rained. Okay. So if it is not rain, the premises say that it is not rain. Okay. Then these all things are happened. Okay. So next conclusion, the similar way, with the help of these rules we can discuss here. R stand for it rained, F stand for it foggy, and S stand for the sailing race will be held, and D stand for the life saving demonstration will go on, and the T stand for trophy will be awarded. Okay. Then because the statement said does not. Okay. So that means if the rain does not here, if it does not rain, or means here disjunction, or if it is not foggy. Okay, here we have taken it is foggy, so we have to take the negation of F. Okay, then means implication. Then the sailing race will be held. the sailing rail will be held. So here is no need of negation, and the life saving demonstration will go on. Okay, so that means the two things are simultaneously. So you have to draw this conjunction in between. Okay, so this is the whole scenario we have taken here. So here, if S is true and negation of true, that means R. Here, how you can relate that? So if we have taken this whole as a S and this whole as a T, if T is not true, then R is true. Okay, so these are conditions. That is, if it is not rain and if it is not foggy, then implies that the race will be held and the life saving demonstration will go on. Okay, and if the sailing race is held, okay, then the trophy will be awarded. Okay, if sailing race will be held, then the trophy will be awarded, and the trophy was not awarded. The second one is trophy was not awarded. So this T implies that trophy was not employed, negation of T. So that means negation, this implies the R value. That means it is raining. Okay, so this is the way you can draw conclusion. Okay, so here this is the expansion of that. S implies T and the tree. So negation of S we have taken because it is not raining. Okay, so negation of S and the negation of D. So whole negation, because trophy will be not given. Okay, by using the distribution law, negation of S and this is negation of D. You can say that. Okay, which is equivalent to like distribution law. Okay, so this will be again negation of R, that means, and negation of S implies that this, the whole thing, P, A and Q. Okay, so this is the way you can draw conclusion from this various rules of inference. So the second examples we discussed here, everyone enrolled in the university has lived in a dormitory. Okay, and the Mia has never lived in a dormitory. And what's the conclusion here? Two premises are there, the P1 and the P2. The P1 says that everyone enrolled in the university has lived in a dormitory, and the Mia, P2 is Mia has never lived in a dormitory. And what's the conclusion here? Mia is not enrolled in the university. So our target is to determine whether the above mentioned argument is correct or the not correct. So for this we have to understand the predicate logic or the first order logic. So in order to understand predicate logic, we must understand the following: predicates and the quantifiers. So what are the predicates and what are the quantifiers? So first we discuss what are the predicates. Okay, so predicates are the statement involving variables which are neither true or false until or unless the value of the variables are specified. So predicates are that statement involving variables, okay, which are neither true or false until or unless the value of the variable are specified. Okay, if it is said that it is a true, you can say that it is true. If it is said that it is a false, you can say that it is a false. So here X is an animal, X is greater than 3, X is less than 4 and X plus Y is equal to 7. So all the statement are neither true and false. X is animal, I don't know X is animals or human. X is greater than 3, it can be less than 3. Okay, so X is less than 4, it can be greater than 4. Or X plus Y is equal to 7. It's not possible always that X and Y is always 3 and 4. Okay, so they are not propositions. So consider the statement. So here we have taken this statement, X is an animal. So here X is any subject, okay, something we are discussing about. So initially whatever the predicates are there, we have taken X. So X, for X we are discussing in this predicates or propositions, okay. So is an animal is a predicate, X is a subject, and is an animal is a predicate. Refer to the property that is subject to that statement, okay. So X is a subject and X is an animal is a predicate. So hope so you will this understand this is a predicate and this X represent that is a subject here, okay. So we talk about the subject with reference to that predicate. So in predicates logic, statement is divided into two parts. The first part is the subject part and the second one is the predicate part. So usually we denote such statement as a shorthand. Like this, if X is greater than 3 can be represent G of X, okay, where Gx denote the predicate and X is greater than 3 and X denote the subject, okay. So after assigning the value of a variable, the statement become a proposition and has a truth value, either true or the false value. Suppose we have here subject value is equal to 5. So 5 is greater than 3. Is it true or false? Is it true? Okay. And G is 3. 3 is greater than 3. Is it true or false? It is false value. Okay. So based on that subject, you decide this is the true and the false. So in general, so based on the predicate, you can't decide it is true or false. So based on subject with the reference to the predicate, you decide it is the true value or the false value. So finding the truth value of the predicate. How to find? So let's discuss some examples. Px denote the statement X is greater than 3 and what are the truth value of P4 and the P2? Again, X is a subject and greater than 3 is a predicate. So P4, if 4 is greater than 3, it is true, you can decide it is true value, and 2 is greater than 3, false, so you can decide it is a false value. So let's discuss the another example. Let Px denote the statement the word X contain the letter A, okay. And what are the truth value of P orange, P lemon, P true and the P false? So P orange, orange is the subject here, the word orange contain the letter A, yes, so this is the true. So based on that subject with reference to predicate, you will find the conclusion, you will reach at the conclusion this is the true value. P lemon, lemon doesn't contain, so this you can say this is the false value. True, true doesn't contain the A, you can say that this is the false value, and the false contain the A subject, you can say that this is a true value, okay. So let's discuss the quantifier. So previously we discussed what are the predicates. Predicate has two parts. The first part is the subject and the second part is the predicate. With the help of subject and with reference to predicate, you will reach at the conclusion is it true or is it false, okay. So let's discuss the quantifiers. So quantifier are the words that refer to quantify such as, there are two quantifiers, that is the sum and the other one is the all, okay. It tells for how many elements a given predicate is true. Is it true for all values or is it true for some value, okay. So in English, quantifier are used to express the quantities without giving the exact number, okay. It deals with all or it deals with the sum value, okay. Sum can be 1, 2, 3 or anything, okay. So for example, all, some, many, none and few are the quantifier in English. So sentence like, can I have some water? Some, how much? You don't have any specific for some, okay. Jack has many friends and for many there are can be 2, it can be 3, it can be 10, it can be 100, okay. So there is no particular value for many and the for some. When there is no particular value or the standard value to decide, then we apply some quantifiers here. So the two quantifier we will discuss here, that is the sum and the all. Okay, so there are two types of quantifier, that is the universal quantifier and the existential quantifier. So universal, that is universally true for all predicates. If it is universally true for all predicate, then conclusion will be true. Okay, so for P1, for one subject, P1 plus 1 is greater than 1, true. Okay, 2 plus 1 is greater than 2, true. 3 plus 1 is greater than 3, true. So whatever be the subject, the value is always true. That means we can say that whatever be the subject, based on that subject, these predicates are always true. If these predicates are always true, so we can say that for all positive integer, Px is always true. So we can use the quantifier that is equal to universal quantifier. So universal quantifier is represented with the help of this, for all. Okay, so for all x, you can read like that, for all x, Px is true. Okay, so this is the first type, that is the universal quantifier, and the second type is the existential quantifier. Okay, so Qx, let's take Qx be a statement x is less than 2 for 1. 1 is less than true. For subject 1, reference to the predicate 1 is less than 2, true. And for second subject 2, 2 is less than true, that is equal to false. And for third, it is also false. So there is no universal values that is always true. So we can say that it is true for some value. Okay, so if there is some value of x for which Qx is true, so we can is the domain is the set of positive integers. So yes, Qx is true for x is equal to 1. So therefore there is an x for which Qx can be true. Okay, so here we can say that there exists. So this represented by this symbol, that is existential quantifier. That means there exists some value of q for which Qx is true. Okay, so this is the way you decide two types of quantifier. If it is true for all the value, you can say that for all you can use this universal quantifier. If this is true for, if some predicate is true for some subject, not for all subject, you can use this existential quantifier. Okay, you can solve any equation. Okay, so you can use various rules of inference for proposition logic. So based on that, you will find the statement, reach at the conclusion, it is true or it is false. Then we discussed in this video, okay, premises. What is premises? Premises contains the one subject and the premises. With the help of these premises, we discussed this is the true or the false. We reach at the conclusion, it can be true value or it can be false value. Okay, and then we will discuss about the predicates. What are the predicates? What are the subjects? Okay, and what is the this is the subject and this is the predicate. Based on the subject in context to the predicate, we reach to the conclusion it is true or false. Next, we discussed some examples how to check it is true or the false value. Okay, next we have taken again two examples to check truth value of predicates. Okay, now we discussed about the quantifiers. So quantifiers, basically two quantifiers we discussed in the video, the sum and or all. For sum you can use the universal quantifier, and for all you can use the universal quantifier, and for existent quantifier you can use there exist. Okay, so hope so with the help of example you've learned about, okay, you understand about various rules of inference, okay, and the types of quantifier. So thank you so much.